Hi ladies and gentlemen, so for 3.6 we're looking at the fundamental theorem of algebra. So the fundamental theorem of algebra says that every polynomial function has at least one zero where a zero may be a complex number. The corollary of that says each polynomial function of degree has exactly that many zeros as the degree, including multiplicities. And this is something that we've actually already been using and applying in our last example problems. Just now, when we go through the problems in this lesson, we are going to find that we have real zeros and imaginary zeros. So sometimes, even when we look at the graph, we can only get so much of the answer, and we're going to have to go back and use our algebra skills to find those imaginary zeros because graphically we just can't calculate those. So looking at example 1, if we have x to the fourth plus 4x cubed minus x squared plus 16x minus 20 equals 0, and we're going to find all the roots. The polynomial is of degree 4 because that's the highest exponent, so that means there's going to be exactly 4 roots. Those may all be real numbers or some of them might be imaginary. So if we graph this function, so if you type this into the y equals into a graphing calculator or using Desmos, we're going to be able to calculate some of the roots, but then we're going to have to find the rest algebraically. So when you graph this and you calculate its zeros, either again using Desmos or using a graphing calculator, you're going to find that we have zeros at x equals -5 and 1. So what we're going to have to do is we're going to have to go through our synthetic division process twice in order to get something that we can then factor. And it doesn't matter which one of these zeros you start with, you're going to end up with the same answers in the end. So I'm going to start with -5. So -5 is going to go in my box, and I'm going to start my synthetic division process. My coefficients are 1, 4, -1, 16, and -20. Oops, I need a little bit more space there. Carry down the first number. 1 times -5 is -5. 4 plus -5 is -1. -5 times -5 is 5. Combining -1 and 5, I get 4. 4 times -5 is -20. Combining 16 and -20 is -4. -4 times -5 is +20, and I get a remainder of 0. Remember, when we use this process of division, you should always get a remainder of 0. And if you don't, you made a mistake somewhere that you need to look back at your work on. Now, what I'm going to do is I'm actually going to just continue this problem with my next 0 right off of where I ended. So I'm going to tack the 1 on to what I have here. Now my coefficients are 1, -1, 4, and -4. I'm going to draw my line and carry down the 1. 1 times 1 is 1. -1 plus 1 is 0. 0 times 1 is 0. 4 plus 0 is 4. And 4 times 1 is 4. And then we get 0, which is no remainder, which is good. So what we've done is we've taken this original polynomial and we've divided it by the -5. Then we've taken that answer and continued the division with the 1. What that has left us with are these coefficients of 1, 0, and 4. Keep in mind, we originally had something that was a degree of 4. We divided it by something that was linear, which gave us something that was cubic. We then divided that by another thing that was linear, so now we're left with something that's to a power of 2 or a degree of 2. So that 1 is corresponding to a 1x squared. Then it would be like plus 0x plus 4. And again, our goal is to find our roots, so we're going to set this equal to 0. Having a 0x doesn't really do anything for us because it's just 0. So really, we have x squared plus 4 equals 0. Solving that for x, I'm going to have to subtract my 4 over. And that's going to give me x squared equals -4. Then I'm going to square root both sides. And that gives me x equals plus or minus 2i, because we're square rooting a negative number and we're solving for x. So square rooting the negative number is where the I comes into play because it's imaginary. The plus or minus is there because we square rooted the variable, so we have to have the plus or minus. So how does that answer our question? The question says solve by finding all roots. So we have 4 roots total. We have x equals negative 5 and x equals 1 that we found graphically. Using our algebra skills, we found the last 2 because we have a positive 2i and a negative 2i, and that's a total of 4 answers. All right, let's go through the same process again with example 2. We have this power or degree of 4 polynomial. That means in the end we should have 4 answers exactly. I want you to graph this problem to find what your 2 values are from the graph. So if you graph this problem and you look at the table or you look at the graph, you would be able to find that it crosses the x-axis at negative 2 and 1. So those are the first 2 answers that we're going to be working with. And we're going to use these 2 answers to find our other 2 zeros because we know we need a total of 4 because this is a degree 4. I'm going to start with the negative 2 with my synthetic division. Coefficients are 1, 1, 2, 4, and negative 8. Carry down the 1. Starting my process, 1 times negative 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 2 is 2. Combining 2 and 2 to give me 4. 4 times negative 2 is negative 8. 4 plus negative 8 is negative 4. Negative 4 times negative 2 is 8. And I add those and I get 0, which means my remainder is 0, so I know I did the first part of the division process correctly. So I used the x equals negative 2. Now I'm going to use x equals 1. Oops, and I'm running out of room here. Here we go. So I carry the 1 down. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. And 4 plus 0 is 4. 4 times the 1 is 4. And combining the negative 4 and 4, I get a remainder of 0. So, similar to last time, I end up with a quadratic of x squared plus 4 because that 0 in the middle would be like a 0x, but again, that doesn't mean for anything. Solving for x, I would subtract the 4 over, so I get x squared equals negative 4. Square rooting both sides, I get x equals plus or minus 2i. So those are my 4 answers. Negative 2, 1, positive 2i, negative 2i. Example 3, it's our last problem. We want to find the roots again. When working with this one, you can use factor by grouping if you would like, or if you want to use the synthetic division process, that does work as well on this one. Okay, so synthetic or factor by grouping doesn't always work, but the synthetic division process does work every time, which is an option. I do want to remind you what factor by grouping is because you are going to need to know how to do it. So I'm going to use factor by grouping to solve this one. So I'm going to group the first 2 terms together. X to the 4th and 2x cubed have a greatest common factor of x cubed. Ooh, actually, that's fine. And then, so that would leave me with x plus 2 minus 3x squared minus 6x has a greatest common factor of minus 3x, which will leave me with x plus 2. So between the green and the blue term, I have this quantity x plus 2 that is my greatest common factor. What's left when I factor out the x plus 2 is x cubed and minus 3x. And again, we are solving here, so we should have this. We are finding roots or solving for x, so this should be set equal to 0. Continuing my factoring process, x plus 2 is as factored as it can get, so I'm just going to kind of carry that along. I have x cubed minus 3x. That has a greatest common factor of x, which will then leave me with x squared minus 3, and then it would be equal 0. So now everything is pretty much as factored as possible, so now I can begin solving each of these factored pieces for x. X plus 2 means x is going to equal a negative 2, and that has a multiplicity of 1, because it only occurs once. X is going to give me x equals 0, which has a multiplicity of 1, because it only occurs once. X squared minus 3, I have to do a little bit of work. I have to add the 3 over. I get x squared equals 3. I have to square root both sides. And I get x equals a positive square root of 3, which has a multiplicity of 1. And then I get x equals a negative square root of 3, which has a multiplicity of 1. And I know this problem didn't specifically ask us to find the multiplicities, but it's also good just to review that. Notice that this was a degree 4 polynomial in the beginning, and I have 4 answers: negative 2, 0, positive root 3, and negative root 3. All right, so that wraps up 3.6. You're now good to work on the homework.